Microplastics are microscopic pieces of plastic that are smaller than 5 millimeters. Broader definitions include other polymer materials like rubber or tire wear particles, and some include natural fibers that have been modified like dyed cotton materials. So my name is Jeremiah Bryksa. I'm a researcher here at NAIT Applied Research, and for the last 6 years I've been studying microplastics in our local river. Microplastics are not all the same. I remember hearing a quote from someone where they compared microplastics to snowflakes, because I guess snowflakes are all unique. I don't know much about analyzing snowflakes, but I can tell you for sure that microplastics are all unique. One of the challenges with microplastics is that they come in all different shapes, sizes, polymer types. Once the microplastic is in the environment, it becomes weathered to some degree. It can pick up different chemicals, and it already has chemicals associated with its production and use. So all these things contribute to microplastics being categorized as a complex suite of materials. Microplastics are sometimes referred to as emerging contaminants or contaminants of emerging concern. This means that they're on the radar, but they're not yet regulated because we don't know enough about them. So that's why we study them. We want to know where they come from, what happens to them when they're in the environment, where do they go, what are their concentrations within ecosystems, and what is the risk associated with that exposure. From an analytical point of view, there's a lot to be discovered still. The best way to measure microplastics hasn't been figured out yet. So I think there's a lot of room for innovation, and I think that's motivating. One of the things that shocked me the most is how challenging this space is. I couldn't believe how easy it was to contaminate your samples using things like plastic material. We had to learn the hard way here at NAIT in our lab to remove all types of plastic material from our laboratory field processes, because this can lead to contamination. And we want to make sure that when we report our results, we're not reporting our contamination, we're actually reporting their environmental concentrations. To start off, we have to remove all plastic material from our laboratory workflow. We have to wear certain clothes in the lab. We can't wear synthetic materials like polyester because that can lead to contamination of our samples. When we're in the field, we have to stand downwind and downstream of our sample collection, so to make sure we don't contaminate our samples. So microplastics exist at very small concentrations within the environment. Having a robust framework for quality assurance and quality control allows us to avoid contamination and have really good defensible results in the end. So our work at NAIT focuses on measuring microplastics in freshwater. We're looking at microplastics in the North Saskatchewan River as it flows through Edmonton. We want to apply a robust methodology to look at how concentrations change throughout Edmonton and how they change over time. The first section of our methodology is sampling. We want to make sure we take a representative sample of the North Saskatchewan River to bring it back to the lab for testing. Microplastics exist at low concentrations, less than a particle per liter. So we want to make sure we take a large volume of water to be able to find microplastics within the river. Over the years, we've designed a plastic-free portable system that relies on battery power that allows us to take samples anywhere we want in the field. We call this system River Beauty, and we published a paper in 2024 outlining the details to build this system for yourself. So the next section is what we do in the lab. As you can imagine, there's tons of particles in the river, and our job in the lab is to isolate and concentrate the microplastics from the other particles. There's techniques that we use in the lab where we separate the particles based on density, and then we apply different chemical and biological digestion steps to remove unwanted particles. Currently, we have our laboratory method paper in peer review. Once it's published, people will be able to use all our tips and tricks to isolate microplastics from freshwater samples. The science of measuring microplastics has changed over the years. More and more technology has been adapted to this field. Back when it first started 20 years ago, looking at microplastics in the ocean, you could just look with your eyes and you could see these plastic pieces floating. They're big enough. But the problem is, the smaller the particles are, the harder it is to differentiate them as plastic. So you need to use more advanced chemical techniques. Plastic is an engineered material, so it has a unique chemical fingerprint. Using techniques like infrared spectroscopy allows you to actually get a chemical fingerprint of the particle, and you can use it to determine if it's a plastic or not and what type of plastic it is. Here at NAIT, we have various instruments at our disposal to help us analyze small microplastic particles. We have a Raman microscope that allows us to analyze particles down to 5 micrometers. We also have an instrument called a micro-FTIR. This allows us to create large area maps and hyperspectral images which allow us to compare each pixel in the microscope image to a plastic chemical signature enable us to see where we have plastic particles. As this field advances, this technology available to us allows us to see smaller and smaller microplastics. We finished our 5-year project looking at microplastics in the North Saskatchewan River. As the river flows through Devon, Edmonton, and Fort Saskatchewan, will be the largest study ever to look at microplastics in freshwater within Canada. We went to 12 locations around Edmonton and sampled the exact same volume of water year over year, season over season, representing different environmental conditions. We sampled large volume 1,500 liter samples for each sample and brought those back into the lab to isolate the microplastics. We're tracking 8 different plastic types as they flew through the city, and we're able to see if they change as they flow through the city and over time. Right now, we're working on a publication, sharing the knowledge that we learned and contributing to this field and advancing microplastics. We applied a robust methodology for sampling, extraction, and analysis. We can't wait to share it with the public and scientific communities.